Hey everyone, so now we're going to talk about integer operations. And if you remember from one of the last videos, integers are whole numbers, but they're positives and negatives. So this is slightly different than just adding, subtracting, multiplying, and dividing positive numbers like you guys have been doing for the last several years of your life. Now instead, we're going to be adding, subtracting, multiplying, and dividing positives and negatives. So there's just a couple of rules that we want to go over. Let's start with addition. So I'm just going to write add right here. So here's the deal. When we have a positive plus a positive, it has to be equal to a positive. This is like what you are learning in elementary school. We know that 2 plus 3 is equal to 5. If we have a negative plus a negative, this is also a negative. So again, this is really similar to what you were learning when you were younger, but now you're just attaching negative signs to it. The way that I like to think about these, when they have the same sign, we have to add, and then the sign keeps or stays the same. Okay, now what if I have a big positive plus a little negative? Well, that will give me a positive, because what happens is if I say like 10 plus a negative 3, if we think about it on a number line, we have, let's see, so let's say that this is 10, and I said, okay, I'm going to add negative 3 to it. Adding negative 3 is the same thing as subtracting 3, so it would just go backwards, 1, 2, 3. So when I go backwards 3, I get to 7, which means that my answer ends up being positive. So then what if I have a big negative plus a little positive? It's the opposite. So my answer will end up being negative. So the way that I like to think about these two is, I'm just going to erase this number line so I have some space, is that if they have different signs, we subtract. Even though it says add, like we kind of talked about in that number line, if it says add, but they have different signs, we're really subtracting. And then we keep the sign of the bigger number. We'll go through some examples. In fact, let's go through 2 examples right now. So the first example is negative 3 plus negative 1. All right, so both of these are negative, which means that it follows that negative plus negative equals negative rule. And based on what I wrote off to the side, if they have the same sign, we're going to add them. So the way that I like to think about this is I'm just going to say, okay, well, I know that 3 plus 1 is 4, but because they're both negative, my answer is negative 4. And that's it. Okay, let's do another example. Let's do 7 plus negative 8. All right, in this case, we have a positive and a negative. So what I'm going to do is I am going to say, because they're different opposite signs, I'm going to subtract. And it's easier in my head to do the big number minus the little number. So I'm going to say 8 minus 7. Well, 8 minus 7 I know is 1. But the 8 is bigger than the 7, and the 8 is also negative, which means my answer has to be negative as well. So my answer is negative 1. Okay, so now let's go through some subtraction rules. Okay, so here's the deal. Subtraction is actually pretty hard with integers. So instead, what I want you to do is, what we're going to do is convert each subtraction problem into an addition problem and then backtrack up to these rules that we've already talked about. So if I have a positive minus a positive, that's the same thing as saying a positive plus a negative. Okay, and then if I have a negative minus a negative, that's the same thing as saying a negative plus a positive. We'll go over an example of a couple of these, but just be aware on this guy, two negatives cancel each other out. So like if I have, like, let's say I have 2 minus a negative 3, if I have two negatives right next to each other, like what I have right here, it just makes it a big positive like this. Okay, that's the reason why that works. But we'll go through other examples too, I promise. Okay, so then if I have a positive minus a negative, that will give me a positive plus a positive for the same rule that we just talked about, because the two negatives right next to each other would cancel each other out. And then if I have a negative minus a positive, that gives me a negative plus a negative. Okay, so let's talk about one other thing that I have failed to mention thus far. It's the keep, change, change rule. Let me write that down. So keep, change, change. So what that tells me is that when I have a subtraction problem, I'm going to keep the sign on the first number, change the middle sign, and then change the sign on the last number. So let me show you how it works with some examples. Let's say we have 5 minus negative 4. So based on this keep, change, change, I am going to keep the sign on the 5, which means that my 5 is positive. Then I'm going to change the middle sign, which makes it a plus instead of a minus. And I'm going to change the sign on the last number, which makes it a positive 4. So I could write plus plus 4, but you don't need two pluses, which just makes it plus 4. Now let's kind of go back to my rules, because my rules use the keep, change, change rule, but I just want to show you that you could, if the keep, change, change thing is a little bit hard for you to understand, you can just kind of memorize the rules that I wrote out. So on this one, we have a positive minus a negative. So it follows this guy right here. So it should change to a positive plus a positive, which it did. Okay, great. 5 plus 4 is a positive plus a positive, which makes it really easy to figure out. That's 9. But if we still didn't know it, we could go potentially back to this add rule and say, well, we know a positive plus a positive is a positive based on this top rule right here. Okay, let's go through another example. Okay, let's say we have negative 9 minus 5. Okay, I'm going to do that keep, change, change rule again. So I'm going to keep the sign on the first thing, which is the negative 9. I'm going to change the sign in the middle to be plus, and then the 5, this looks really weird because it's minus 5, but the 5 is positive. I could write this as a negative 9 plus a positive 5. So when it changes the sign on the 5 actually goes to negative. And so now I've got two negatives that are being added together. Let's just make sure that kind of checks out with my subtraction rules. I started with a negative minus a positive. Negative minus a positive is this one right here. It should change to a negative plus a negative. Oh, it did? Okay, so negative 9 plus negative 5. Then to backtrack up to my add rules, a negative plus a negative, which is that rule right there, should be a negative, which means that I add them and then just keep that negative sign. Well, negative 9 plus negative 5, well, 9 plus 5 is 14. And then because they're both negative, my answer is also negative. All right, awesome. Okay, so now let's just go through multiplication and division. So here's the deal. Multiplication and division have the same, both have the same rules. So I'm just going to write one set of rules. Okay, so if we have a positive times a positive, that is equal to a positive. Now, all of these rules, I could switch the times to a divide and they would still work. If I have a negative times a negative, that is also positive. If I have a positive times a negative, it is a negative. If I have a negative times a positive, it is a negative. So the way that I like to remember these is if they have the same sign, my answer is always positive. If they have different signs, my answer is always negative. Another great way that I learned how to remember this is kind of with a tic-tac-toe board with, let me think about this, positives down the middle, and then everywhere else are negatives. So if you read the top row, it's P and N, which really says like the positive times the negative is equal to a negative. And then the middle row says negative times a positive is equal to a negative. And then the last row says negative times a negative is equal to a positive. If that's an easier way for you to remember it versus my rules, that's totally cool. Okay, let's just go through two more examples. So number 5 is negative 6 times 2. So this is a negative times a positive. Well, those have different signs, which means my answer automatically has to be negative. The way that I'm going to do this, though, is to think, well, I'm just going to do 6 times 2. 6 times 2 I know is 12, but I know that because it has different signs, it has to be a negative. So my answer is negative 12. All right, and then last example is negative 10 divided by negative 5. So remember, all of these rules that I just wrote up here are also applicable to division. So I've got a negative divided by a negative, which would follow this rule right here. Because they have the same sign, my answer has to be positive. I'm going to just say 10 divided by 5. Well, I know that's 2. And because they're the same sign, it's positive. My answer has to be positive, which means my final answer is 2. And there are the rules to integer operations.